So you're gearing up for your university admission tests, right? You know the math section is just a flat-out race against the clock. And those integration problems, man, they can eat up so many precious minutes. But what if I told you there's a secret playbook, a way to solve them in just a few seconds?
Okay, picture this. You see a problem like this one on your test paper. The clock is just ticking away. Tick, tick, tick. Your heart starts pounding a little faster as you think about all the steps you'd have to go through. It almost feels like it's designed to slow you down, doesn't it?
Well, that's where this comes in. I want you to forget the long, complicated textbook methods, just for a moment. See, there are patterns, there are shortcuts, there are even what I like to call secret handshakes hidden inside these problems. And in this explainer, you and I are going to crack that code together.
All right, let's dive right into our first play. This pattern shows up all the time with exponential functions. And yeah, it's designed to look super intimidating. But once you see the trick, I promise you'll be able to solve it in a fraction of the time.
Now, just look at this contrast. It's night and day, right? On the left, you've got this big, ugly, complex-looking integral, and on the right, that's the answer. I know it seems way too simple to be true, but this shortcut works every single time if a very special condition is met.
And here it is. This is the condition. This is what I call the secret handshake. Before you do a single bit of math, you just check the exponents. If the difference between the exponents up top, that's m minus n, is exactly equal to the difference down below, p minus q, then you're in. The shortcut is unlocked.
Let's see it in action. In this example, m is 9, n is 5. So 9 minus 5 is 4. Okay. Now in the denominator, p is 2, q is negative 2, so 2 minus negative 2 is also 4. The handshake is confirmed. So now we just plug our values into that simple shortcut formula, e to the m minus px over m minus p, and boom, problem solved. No long derivation needed at all.
Okay, let's move to our next play. This one really builds on this whole idea of spotting patterns. And this isn't just a trick for one type of problem, this is a fundamental technique. I call it the ultimate time saver because it literally turns multi-step problems into one-line answers.
Now take a look at this one. I bet your first thought, your training, tells you to use partial fractions. Factor the denominator, set up all those equations. It's a total time sink. It's what they want you to do. But someone who's really mastered these tests sees something else. They see a hidden relationship.
And here is that key insight. Look closely. The function in the numerator, 2x plus 3, is the exact derivative of the function in the denominator, x squared plus 3x plus 2. When you see this pattern, a function on the bottom and its derivative sitting right there on top, you have hit the absolute jackpot.
To make this totally unforgettable, I want you to think of it like this. If someone asks you to integrate the derivative of the Earth over the Earth itself, the answer is just the natural log of the Earth. The rule is that the integral of f prime of x over f of x is always ln modulus of f of x plus c. It really is that simple.
So now for the really cool part. This master key pattern, it's not just for those algebraic fractions. We can use this exact same logic to instantly solve some of the most common trigonometry integrals that you are definitely going to see on your exam.
Take, for example, the integral of tan x. So many students just memorize the formula. But have you ever wondered where that formula comes from? Well, it comes directly from our pattern spotting technique. The answer is literally hiding in plain sight.
Here's how you should think it through in the exam. First, you rewrite tangent as sine x over cos x. Now look at it with our new pattern spotting eyes. The denominator, our f of x, is cos x. Okay, what's its derivative? It's negative sine x. Now look at the numerator. We have sine x. It's almost perfect. It's just missing a negative sign. But that's easy. We can adjust for that, which leads us straight to the answer, negative ln yen.
And what's so amazing is that this one core idea unlocks all of these standard trig integrals, you see? Instead of just brute force memorizing 4 different formulas, you now understand the fundamental principle that connects every single one of them, and that is the key to real mastery.
So what's the big takeaway from all this? Success in these timed exams isn't about being some kind of human calculator. No way. It's about being a pattern detective. You need to start building a mental playbook of these kinds of shortcuts. So let's review our playbook. For those exponential fractions, the first thing you do is check for that secret handshake. For any fraction, you always scan for that f of x over f of x relationship before you even think about slower methods. This one pattern is your master key. The core idea is simple. Stop just calculating and start seeing.
You see, with this new mindset, you're not just solving problems one by one anymore, you're building a whole new framework for seeing the hidden structure of math. So the final question I'm going to leave you with is this. What other patterns, what other shortcuts are hiding right there in plain sight, just waiting for you to discover them?